increasing and decreasing function. An increasing function is the function that is increasing from left to right. So thinking as you are a person walking and then you hit the slope and the slope going up. So that is increasing. And the next one, well, you start walking and then you hit the slope that is going down. So that is a decreasing graph. Okay. So we want to find the domain and range of this function f of x and approximate the interval in which f of x is increasing and decreasing. So first I go ahead and sketch the graph using Desmos. And this is what I get. Now notice that this graph is increasing from negative infinity all the way to this top point, that is negative 1.55, and then it's decreasing, so it starts going down and decreasing to this point at 0.22, and then it increasing from this point up. Okay, so after sketching the graph, I can write the interval in which the graph is increasing or decreasing. So it's increasing from the interval of negative infinity to negative 0.55 union with 0.22 to positive infinity, decreasing in the interval of negative 0.55 to 0.22. Now, because f of x is the polynomial, the domain is negative infinity to infinity, and same with the range. So let's talk about the maximum and minimum value of the function. The function value f of a is a local maximum of f if f of a is greater than f of x, where x is near a. So if you're talking about this point, say this point is f of a. This value here is bigger than all of this value around it. Here's another f of b. Well, f of b, even though it's less than f of a, it's still bigger than all the value f of x around it. So this is called the local maximum point. The local maximum is just to that specific area, not to the, unless we're talking about a global maximum, then it is the maximum out of all the local one. Again, here's the local minimum. That is the smallest point on the graph compared to all the one that close to it. Okay, so let's take a look at the next problem. Well, the graph of f of x equal x to the fourth minus 4x to the third plus 2x squared plus 4x minus 3 is given. We want to state the domain and rank of f of x. Well, the domain, it is the polynomial, so the domain here is all real number. Well, the range, notice that the lowest point on this graph, is negative 4. So that is from negative 4 to infinity. State the interval in which f of x is increasing and decreasing. Well, f of x increasing, as you can see in this point, increasing. So we're talking about this part and this part. Increasing from negative 4 to 1, and from 2.14 to infinity. 414. Decreasing. So decreasing, we're looking at this portion. Negative infinity to, increasing. So we're talking about the x value in here. So the x value is this part. Negative 0.414 to 1. So decreasing from negative 0.414, union from 1 to 2.414. So say the maximum and the minimum value of the function and the x in which each occurred. The minimum value is talking about the y value. Okay. So maximum at x equal to 1 and f of 1 is equal to 0. Minimum, just 2 points right here, at x equal to negative 0.414, where f of negative 0.414 equal negative 4, and at x equal 2.414, and f of 2.414 also equal negative 4. So the maximum value is 0 at x equal 1, and the minimum value is negative 4 at x equal to negative 0.414 and at 2.414. The graph gives a self-representative distance from his home as a function of time on a certain day. Determine the time interval on which his distance from home was increasing and those on which were decreasing. So his distance from home increasing from 8 to 9, and then he stayed at that same spot until 10, and then increasing to noon, and then he stayed there until 1 o'clock, and decreasing until 3, and increasing to 4, then decreasing from 5 to 6. So increasing. So the part that his distance is gone up. So increasing from 8 to 9. Union from 10 to noon. And from 3 to 5. Decreasing from 1 to 3 and from 5 to 7. Describe in words what the graph indicates about his travel on this day. So at 9 to 10 a.m. he was at the same spot. So he wasn't walking. And then he take a break from noon to 1. Okay. And then he took another break from 5 to 6. So his distance increasing. He started walking from 8 to 9 and from 10 to noon, and from 3 to 5. Then he started heading back from 1 to 3 and from 5 to 7. Find the net change and the distance from home between noon and 1. Okay, so at noon, his distance from home is right here. Yeah, whatever that is, f of a. And f of noon, so f of 12. And the distance at 1 o'clock, well, from noon to 1 he rests, so the distance don't change, so that it equal to each other. This means the net change equal to 0, because obviously he take a break, so he doesn't go anywhere. So the net change is 0. The gravity near the moon, we can use Newton's law of gravity to measure the gravitational attraction between the moon and spaceship using this formula. F of x equal 350 divided by x squared, where f measured in Newton and x is the distance between the spaceship and the surface of the moon measured in millions of meters. Graph the function f of x for the value between 0 and 10. Then use the graph to describe the behavior of gravitational attraction f as the distance x increase. I'll go ahead and use decimal for this graph. And okay. So as we can see, if x is the distance between the spaceship and the moon, and y or f of x is the gravitational pull from the moon to the spaceship, that we can see as the spaceship gets away from the moon, the gravity acting on the ship is decreasing, right? And when x is 10 million meters away from the moon, the force that acting on the spaceship is 3.5 Newton.